Hello everyone. So today we are going to solve today's LeetCode daily problem. So problem number 3418, maximum amount of money robot can earn. Okay. So let's read the problem statement. You are given an M cross N grid. A robot starts at the top left corner of the grid, that is 00 cell, and wants to reach the bottom right corner, that is M minus 1, N minus 1. Okay. The robot can move either right or down at any point in time. Okay. So the robot can only move in two direction, either right or down. So whenever you will find in a grid problem, anyone are basically restricted to move in either left or down or up. Like in such directions where the graph won't be cyclic, then you can there is high possibility that the problem is a DP problem, basically. If a robot can move in any direction, it is basically a graph problem. And if it only can move in right or down, then most probably it is a DP problem, like most of the cases. Okay. So the grid contains a value, coins of ij in each cell. If a coin is positive, the robot gains that many point. Okay. And if the value is negative, the robot encounters a robber and the robber steals absolute value of the. Okay, basically, so negative means he will lose that much coin. Okay. The robot has a special ability to neutralize robbers in at most two cells. Okay, on its path, preventing them from stealing coins in those cells. Okay. So basically, what he can do in those cells, mm, the robbers has the special ability to neutralize robbers in at most two cells on its path. So basically, if on its path, if there is any negative number, generally that signify that that much coin the robot will lose. But he has the special ability to neutralize in two cells, basically where he won't lose any coins. Basically, the robot's total coin can be negative. Yeah, return the maximum profit of the robot can gain on the robot. So basically, if I summarize the problem statement, we have a grid of M cross N. In every cell, there is a value, and the robot can only move either to the right or bottom or down. And like he will collect the coins on its path. If it is positive, it will increase its gain. If it is negative, it will decrease its gain. And he has the ability to basically, we can say, he can replace at most two cells with value 0 basically. If there is negative value, he can replace it with 0, and you have to find the maximum profit he can gain on the route. So it's just basically simply DP problem, straightforward. So what we are going to do basically, let's say we have a grid here, and the robot can move only down and right or down. So we will form a DP. Let's say DP of I comma j comma k. So what does it mean? DP of I comma j comma k is the definition where basically we are in I comma j cell, and k is the number of cell we have already neutralized the value. So k can be up to 0, 1 and 2. Basically at most he can neutralize two cells. Na? So dp of ijk is the definition of the dp of ijk is the maximum coin the robot can collect if it is on I comma j cell and it has performed k neutralize operation. So if the robot is in this cell, he can came to this cell from either its upper cell or from the left cell. So if it is in ij, I comma j, so it can came from I minus 1 comma j or I comma j minus 1. Okay. So what will be the states of the DP? So if he does not want to neutralize or do any operation on that cell, So the DP state will be simple. Basically, he will collect its point, and the coin he can collect either from here or here. So we'll take maximum of these two cells. So basically, if I don't want to, basically if I perform no operation, no operation, let's write it in the editor. So basically, if there we have two choice, na. So let's first write the definition of the DP. DP of I comma j comma k equal to maximum profit. Maximum profit the robot can gain if it is at the I comma j cell and already and basically perform a neutralize operation. Neutralize operation. It is the definition. Now let's write the state of the DP. So what will be states? So basically if I perform no operation, then DP of I comma j comma k will be simply, as I am not performing any operation in the current cell, so I will simply collect the coin at the cell ij, plus I can take from either its upper cell or lower cell with the same number of operations. Basically, we will collect maximum of dp of I minus 1 comma j comma k comma dp of I comma j minus 1 comma k. So this is if I perform no operation in the current cell, we will simply basically collect the coin from the current cell, and we will uh, choose the maximum value from its upper cell or the left cell with the same number of operations. Okay. Now another choice is if I perform a operation. So in that case, dp of I comma j comma k equal to, as I am neutralizing this cell, so basically replacing this cell with 0. So I will not collect any coin. I will just simply collect the value from its upper cell and the left cell. So it will be simply max of coins of I minus 1 comma j comma k minus 1, because we are performing according to the definition, up to this cell we have performed k operation, and we are sure that we are performing one operation in the current cell. So we have to collect the value from the previous cells with k minus 1 operation. So and similarly dp of I comma j minus 1 comma k minus 1. Okay. And we will the answer will be the maximum of these two. So this is the definition, this is the states. So rest is simple. So let's write the code. Okay. So coin dot size is 3 coins of 0 of size. Basically, according to the question, the cell is m cross n, but I'm taking it n cross n grid. Same. Now I will declare a dp of I comma 3d dp. So vector of uh, vector of mm, dp of n comma. Basically, don't let's not write like this. No? In modern C++, like C++20 or newer versions, we can declare multi-dimensional vector like this. So we'll simply go with aim, comma vector, comma 3, comma. Basically, what will be the dimension of our vector? The dimensions will be, um, let's declare it simply, no? Int dp of n comma m comma 3, because n m and 3 is the value of a at most. And size, because the value can go up from 0 to 0 to 2, 0, 1, 2. Now let's write the base case. So dp of 0 comma 0 comma 0. So if I am at the starting cell and I'm not going to perform any operation, so the answer will be simply the value at that cell, the value at 0, 0. And the rest of the thing like 0, 0, 1 and dp of 0 comma 0 comma 2. So if I'm in current cell and I'm performing either one operation or two operation, that means that uh, I can replace that value with 0 if it is negative. So I'm going to simply go 0 comma coins of 0 comma 0. Okay, this is the base. Okay, now let's look to the grid. For int j0, j less than n, okay, and k. K will go up to 3, I mean up to 2. So we are going this. Now if I equal to 0 and j equal to 0 means the base case. We have already covered it, so let's continue this. And here uh, no operation. So if I am going to go with no operation, we will simply take this value coins of ij plus max of dp of ijk and dp of okay, that's cool. And if I am going to perform a operation, then its value will be simply this. And dp of I comma j comma k equal to max of operation comma no operation. It can take not take it. And what will return? We will simply return like dp of n comma 1 and minus 1 n minus comma 2. Really, we will return the maximum profit we can gain at the last cell if we apply two operation, because if like it is the optimal answer can be gained through one operation, then it will also be possible to gain through two operation basically. Mm, that looks good to me. Okay, so one thing is there, we are accessing its previous index. So if I value is 0, then this will be negative 1. So it will be out of bounds. So for that, we need to apply some checks that this does not like go out of bound. So let's write a function for that. So f in I comma j comma int k. So what it will do? it will basically return the value at the dp of ijk. Return dp of I comma j comma k. But if any one of these index goes out of bound, means if I less than 0 or j less than 0 or k less than 0, then it will return. Let's say what should we return? Basically, it is an invalid query, na? So for invalid query, as we are going to maximize our profit, so let's return negative infinity. Right. Uh, let's declare infinity here. 186 should be good. What is the constraint? 1500. 180 is good. So now here we will just replace this dp with the function if comma I minus 1 without j comma k, and here if of I comma j minus 1 comma k. Okay, this should be dp, not columns. Okay, so let's replace this with I minus 1 comma j comma k minus 1, and here f of I comma j minus 1 comma k. Format the code. It should work. Let's run this. Yeah. Getting wrong. Okay, no problem. I've got nm. This is a function. We will return negative infinity if n is 0. Otherwise, it will return the index. Base case is this. I'm going to go with no operation in this, and if I'm going to go with any of the operations, then this should be this maximum of 0 comma 1. Yeah, that good. And if I'm going to perform no operation here, then points of ij, I'm going to take this and maximum of f of I comma 1j, I comma j minus 1 comma k. That's good. And here also operation maximum of, basically, do I need to give here that maximum of 0 comma coins of I comma j, and I minus 1 j k minus 1 I comma j. Oh, for this reason. Basically, we don't need to give this. Okay. This should work. Let's submit this. Yes, it got accepted. So this was the intuition for this. So this was the definition of the DP, and the states there were simply take or not take, like kind of either you perform a person or not. Then just write this. What will be the time complexity? Like you can basically time complexity is very simple. The states of the number of states of the DP n cross m cross 3, which is order of m cross m. And this looks are good. You can basically optimize the space a little bit, because we are only accessing the leftmost cell and the uppermost cell. So instead of declaring the whole DP, you can uh, keep the track of the only previous row and the current row. So you can optimize the space a little. It's okay. So thank you. This is for today. Thank you. Bye.